Hello, I'm Quarcoe Yvonne, and today I would like us to study in data path cycle and instruction execution under the course Computer Architecture. So, moving on, I would like us to know why understanding the CPU functionality is critical for computer performance. So, we'll be looking at data path. So data path is the hardware responsible for transferring data within the CPU. So components of the data paths are arithmetic logic units, registers, multiplexers, and bus. So I'll be explaining them one after the other. So first we'll be taking the arithmetic logic unit. So the arithmetic logic unit, as we all know, performs mathematical and logic calculations such as addition, multiplication, subtraction, and many more. It also takes data from registers or memories, perform operations, and store the results into the register or memory. The second point, registers. Registers are small, high memories. They are small, high speed memory located within the CPU. They store data temporarily whilst it's being processed by the CPU. Okay, multiplexers. Multiplexers are digital circuits that select one or several input signals and forward it to a signal output. But in the content of the CPU, multiplexers are used to select which data to send to the arithmetic logic unit or the registers. So the bus. The bus facilitates communication between components, enabling data exchange and control signals. So the importance of data path cycle. So data path cycle ensures effective data movement between memory, arithmetic logic units, and registers. 2. Directly affects the number of instructions executed per second. So example, fast arithmetic logic unit operation but slow memory access can limit overall performances. So impact on CPU performances. So we have factors affected by data path. So instruction throughput. So the instruction throughput, that's point one, is the number of instructions processed per second. So the number of instructions processed per second is instruction throughput. Latency. Latency is the delay between instruction start and the completion. So the time we take to start or execute an instruction and then the period it takes to complete it is the latency. So parallelism. Parallelism is the efficiency in handling multiple operations simultaneously. Okay, so optimization structure. Sorry, optimization strategies. So optimization strategies, we are looking at pipeline implementation. So pipelining is a technique where multiple instructions are overlapped or in execution. Pipelining is a technique where multiple instructions are overlapped in execution. Okay, so why should you use pipelining as an optimization strategy? So pipelining increases the CPU throughput. That's the number of instructions completed per second. So it increases the number of instructions completed per second or processed per second. And multiple instructions are being processed at once. So with the pipelining, multiple instructions are being processed at once. Okay, let's move on. So our next subtopic or our next topic, that's instruction cycle. So instruction cycle is a reoccurring process that the CPU uses to execute instructions. So here are the list of some phases that the instruction cycles go through. So we have fetching, decoding, and execution. So fetching instructions. The CPU retrieves an instruction from memory, that's the address stored in the the program counter. The CPU retrieves an instruction from memory. Okay, so the process. PC send the address to memory. Instruction is loaded to the instruction register. Okay. We have decoding. Decoding, the CPU translates the fetch instruction into signals for hardware operations. The components involved are the control unit, thus it interprets instructions. Decoders, they translate opcodes and operands. Okay. So the execution instruction. The arithmetic logic unit or other component perform the specified operation. So processing. So these are the processes. The processes it goes through. So the arithmetic logic unit, that's it perform calculations, and then the memory loads and store data. So in this diagram, it's just a sample or a diagram to just show how the phrases are done or how it goes through. So here we have the RAM. So the data is being fetched from the RAM. The data is being fetched, or the CPU fetches instructions from the RAM and sends it to the register. So here it decodes the information, and the information is being executed. After the information is executed, the information is then processed back into the RAM. That's the newly processed information is then stored back into the RAM. Okay. So the relationship between data path and instruction cycle. So efficient data path reduce the time for fetching, decoding, and execution phase. 2. Poorly designed data path can prolong instruction cycle phase, limiting performance. Optimization techniques. Data path optimization. So use of faster interconnections, that's the cache memory, and minimizing pipelining hazards. So pipelining hazard is a situation where the instruction cannot execute in the next clock cycle. An example of the pipelining hazards we have, or types of it, we have data hazards, control hazards, and minimal. They are minimal. Yeah. So for the instruction cycle improvements, we have instruction prefetching. For the instruction prefetching, is a technique where the CPU retrieves instructions from memory before they are needed in the execution pipeline. Okay. Reducing decode complexity. So reducing decode complexity is the process of translating instructions into control signals for execution. Parallel execution unit. Parallel execution unit allows the CPU to execute multiple instructions simultaneously by having multiple functional units. Okay. So in conclusion, data path cycle the data path cycle are integral to CPU performance. 2. Understanding and optimizing the instruction cycle ensures faster and more efficient processing. 3. A well-designed CPU maximizes both speed and efficiency through a balance of hardware and control units. So this brings us to the end of my presentation. Thank you very much.